Hello and a very good day to you, Dr. Vorthanepin. Before we begin our presentation, I would like to introduce our group member. We are from Group 9 and will be presenting our Mechatronics project, which is Smart Wet Market Food Quality System. And our team consists of Arief Hazim bin Muhammad Rizal, Amni Wafiy bin Kamaruzaman, Judah Balakrishnan, me myself Mirza Danial bin Muhammad Asri, and Muhammad Afiq bin Fakhrul Zakee. The presentation content consists of introduction, capabilities of proposed design, literature review, major components, sequence of event, design system, system block diagram, ladder diagram demonstration, and conclusion.
Wet markets are locations beloved by the community for supplying fresh produce and are a staple part of the social ecosystem. Although these systems have been out of date and lack in comparison to competition like supermarkets in their level of quality. The produce in wet markets are inconsistent in their quality and they are hard to keep track of. Customers also may have difficulty in trusting the wet markets, even more so due to the recent epidemic. Therefore, it would be helpful if an innovation for this niche and important component of communities in society gets an upgrade. A smart wet market food quality system that applies a programmable logic controller. Fishmongers and butchers in the wet market rely on a particular principle that supports their careers and produce: time. Their livelihood depends solely on how well they can provide for their customers quality produce early in the day and help them guarantee fresh produce. The time period of selling in the wet market is also unpredictable, and maintaining the produce temperature and acidity constantly is a challenging task for them, as they must also sell while keeping freshness.
Now moving on to the objectives. The first objective will be to monitor the shelf life and the condition of the wet foods throughout the operating hours by implementing temperature and acidity sensors. Second objective would be to notify the trader of the shelf life and the condition of the wet foods by installing alarms based on the conditions of the wet foods. Now, diving into the scope of design. This project is designed to manage a wet market food freshness through detection system in the holding area of the meats. Now, the tools applied are acidity sensor, temperature sensor, along with alarms for each sensors and for the whole system. Also, by utilizing the PLC to set time constraints, actuators, and tracking systems to ensure the freshness and quality of a wet market produce.
There are 4 different capabilities of the smart wet market food quality system. The first one is it can detect the temperature change that will dispense ice to cool down the wet food or ingredients. Next, it can detect the pH value of the wet foods or ingredients, which will trigger the pH alarms and notify the trader or the owner when pH value of the wet food or ingredient is too low. Next, it can keep track of the shelf life of the wet food or ingredients, which will trigger the shelf life alarms and notify the trader or owner when the wet food or ingredients have exceeded shelf life. Lastly, the capabilities of the proposed design is it can install the shutdown button on each alarm, and the whole system which the trader or owner can manually choose depends on the condition itself. There are 2 different types of the literature review that we're going to take a look. The first one is programmable logic control, or also known as the PLC. A control system must be developed so that the automation part is easily programmable, versatile, durable, and cost-effective. PLC are a computer-based and single processor device that emulate the behavior of an electrical ladder diagram. PLC are capable of controlling many types of industrial equipment and entire automated system. It are not only efficient but also very reliable in applications involving sequential control and the synchronization of auxiliary elements. PLC has a great advantages as it can change the PLC ladder diagram after it has been built or worked. The next part of the literature review is actuator. There are 3 different types of actuator, which is electrical, hydraulic, and pneumatic. All actuators are restricted due to their size, complex auxiliary equipment, frequent need for the maintenance, and sluggish environment in renewable application, except for the electrical actuator. Actuators is a vital component of any physical system, enabling movement by converting an energy source into another, for example, electrical, air, or hydraulic. The major application of the actuators are in automotive industry, furniture ergonomic, automation, industrial machinery, etc. Lastly, the pneumatic actuators represent the main force control operation in many industrial applications. On the bottom there are two different types of pneumatic actuators, which is double acting linear pneumatic actuators and also the vane rotary pneumatic actuator.
Our smart wet market food quality system consists of 7 major components, which are the PLC controller, start button, stop button, alarm stop button, sensors, actuators, and a timer. The PLC controller manages the entire system of the smart wet market food quality system. Start button initiates the PLC system for monitoring and temperature control. The stop button shuts down the PLC system for emergencies or during the downtime. The alarm stop button shuts down shelf life alarm notification after produce exceeds the duration. The sensors are the acidity sensor, which measures the pH level of the produce. Temperature sensor monitors the environment temperature of the produce. Actuators: main alarm to indicate acidity and temperature if out of control, and the shelf life alarm to notify that the produce is expired, and the ice dispenser to reduce the temperature or neutralize the pH levels. And the timer tracks the produce duration and triggers an alarm after exceeding its shelf life.
In terms of the sequence of events for the smart wet market food quality system, it will begin by pressing the start button, and from there the system will be started. So the temperature and the acidity data will be taken from the data logger, aka the temperature sensor and the acidity sensor, and from there it will check is the temperature out of range. In case that the temperature is out of range, it will dispense the ice cube. But if it is still not back within the suitable range for the wet food, it will keep dispensing ice until it is, and it will stop dispensing the ice. And in case for the pH value, regarding if the pH value is too low, it means that the food is already bad. So it will sound an alarm and requires a personnel to stop it manually for in terms of the alarm, as the food needs to be checked properly since it is already not suitable for consumption. And the third function would be the shelf life timer. This shelf life timer is the data or the time set by the user in regarding on how long can this food be displayed on the shelf. And in the case that the timer has run out, an alarm will be sounded, and again a user interface is required, as they need to press the stop button to stop the alarm, as the food is also not suitable for consumption anymore. And from there, this system will be in continuous monitoring system. And let's say that if there is any problem, or you just want to shut down the system for the day, you can just press the stop button and it will cause the PLC system to shut down. And that is regarding of the sequence of events.
So I'll be talking on the system's design. The overview is PLC control system for monitoring and preserving food quality, automates processes using sensors, actuators, and timer. Input devices sensors, which are going to be used, is the acidity, the temperature sensors to detect the freshness of the pH levels of the food, and to monitor safe storage conditions. The PLC logic is process sensor data and controls actuators based on threshold. The output device is the actuators, the ice dispenser, the main alarm, and the shelf life alarm, which is to reduce the temperature, alert if there's unsafe pH or temperature value, notifies expired products. And the user interface is simple. It starts, stop, and the alarm stops button for the control. The data logging records sensors reading and systems actions. The advantage of this is ensure food safety and reduces waste and streamline operations.
Regarding the system block diagram, so first let's begin with regarding of what data is the sensors or the input is taking. So we have an acidity sensor and the temperature sensor. So it's taking in analog data regarding the temperature and also the pH value. And from there, our output would be the actuators, which would be the ice dispensers and also the alarm. So we have two different alarms, the shelf life alarm and also the pH value alarm. So this will output a digital type of data, as is either turn on the alarm, turn on the dispenser, turn off the alarm, or turn off the dispenser. So, and how does the data being communicated? So the input will send the data into the PLC data logging, and from there the data logger will communicate with the PLC controller. And from there, it will decide on what output should happen. So it's a continuous monitoring system. So all of these systems are being powered by the power supply. And in terms of how the human machine interface works, we have the start button to start the entire system, and we have three different stop buttons. So the first stop button will shut down the entire system when we need it, and the other two will stop the shelf life alarm and also the pH value alarm.
Hello, my name is Mirza Danial, and I'll be demonstrating the PLC ladder diagram of our smart wet market food quality system. And now, the components used for this PLC system is the start-stop button, sensors, shelf life, temperature high, evaluation, ice dispenser, shelf life alarm cut off, pH alarm, and pH alarm cut off, repeat action, and pH load. Now, on the first rung, there is the start button and repeat button, both used normally open. Meanwhile, the stop button used normally closed. And the expected outcome will be the components of sensors and shelf life with on delay timer. From those two actions, it will result to the input on the second rung. For the second rung is the shelf life. When it is inputted, the result on the second rung should be the shelf life alarm. In the meantime, it also triggers the sensors based on the first rung that would begin the evaluation. Now, the evaluation consists of two inputs. That will be the temperature and pH values. Now, for each of those, the outcome will be ice dispenser for the detection of high temperature. Meanwhile, for the low pH value, it will trigger the pH alarm. The pH alarm. With that being said, also there is the pH alarm cut off. Now, from either of these two outcome, it will trigger the repeat action button. Hence, it will repeat until either of these input is not triggered anymore. So let's begin the demonstration. I've put the shelf life for the sake of the demonstration for 15 seconds. Hence, we'll begin. So, as you can see, when it turns on, only sensor begin. Meanwhile, there is no detection yet. So let's wait for the shelf life first. Now, when it has triggered, the alarm will cue. It will result in notifying the traders that that certain wet produce has reached its shelf life. Thus, the trader has to go and check on its condition. Should it be well to continue to sold or not? Hence, he or she will manually turn off the shelf life alarm. Now, going to the evaluation, either or, if the temperature in the system is high, hence it will trigger the ice dispenser and cool down the wet producers. As you can see, when it triggered, it goes to the repeating action. So it also can be seen that from the low pH value as well, the alarm will be triggered and notifying that the trader should inspect the wet produce condition and freshness of it due to the wet produce having low pH value. Hence, this is also can be manually turned off. When the wet produce, that certain wet produce has been brought out from the system, sensors would be turned off. Hence, this is our PLC ladder diagram demonstration.
So from this project, The conclusion they can make from this is the smart wet market food quality system automates the monitoring and the maintenance of product quality using a PLC controller. It ensures food freshness by tracking acidity, pH, and temperature levels and managing product shelf life through a timer. System takes corrective actions via actuators such as activating alarms or dispensing ice based on real-time data from sensors. Thank you.